Hello, it's Dr. Mears, and today we are going to be looking at problems involving quadratics. This is the area problem. A rectangular mirror has a perimeter of 260 centimeters. Let's remember that perimeter is all the way around a certain shape. So we have a rectangular mirror, so all the way around here, the perimeter equals 260 centimeters. The length of the mirror is x. So instead of writing the letter L, I'm going to use x. So both of these lengths are going to now be known as x. We're going to need to find the width of the mirror in terms of x. So I need to find what W equals here, but I can't write the letter W. I need to write everything in terms of x. So we're going to need to use the perimeter formula. So let's write down P equals 2 times the length plus 2 times the width. The reason why it's 2 is because there's two sides, 2 lengths, 2 widths. Now we know that the length is going to be x, so in place of L, I'm going to put x plus 2W. We also know the perimeter, so notice I didn't write down P because I'm going to take P out, and in its place, I'm going to put 260. So now I have an equation, 260 equals 2x plus 2w. Now I need to solve for w, so I need to come out with something looking like w equals. So let's bring over everything we have here, all of our terms, to the other side. The first one that we're going to move is the 2x. It is being added to the 2w, so we're going to look, this is positive, so I'm going to subtract 2x from both sides. Now here's the thing, I cannot combine these because the 260 does not have a variable x next to it attached by multiplication. So I simply just write down everything I see. The 260, the minus, and the 2x all come down. So I'm left with that equaling 2w. I'm almost done because remember, I need to get the w by itself. What's next to the w? The 2, and it is linked by multiplication, so what we have to do is we divide. When we divide, we have to remember to divide by everything. It is very important that everybody gets divided by 2. So now my w equals 260 divided by 2, 130. Negative 2 divided by 2 is negative 1x. I'm not going to write the 1 here. You should know if you want to write it, you can. I'm not. So our width is 130 minus whatever our length would be. Remember, x is length. 130 minus x. So this is called finding our width in terms of x. So instead of writing w, I can write 130 minus x. Okay, part B. Find the equation for the area of the mirror, area centimeters squared, in terms of x. So again, we're going to have to write down our area formula. Area is length times width, but we cannot use L and W. We can just use the letter x. So let's substitute in what we have. We know the length is x, so x. This is multiplication, so times. We know the width is 130 minus x. Now, I don't want you to leave it like that. I want you to distribute. So this x and this 130 minus x, this is linked by multiplication. So I want you to distribute your x so that we can get rid of the parentheses. I do not want the parentheses there. So here we have 1x times 130. That gives us 130x. We have x times so we have 1x times negative 1x. That gives us a negative 1x, and because there's 2 and we're multiplying it by them itself, squared. So x times x is x squared. So this is the area now in terms of x. So instead of L and W, I have it in terms of x. Okay, part C. Sketch the graph of your equation for the area of the mirror showing area A on the y-axis and length on the x-axis. So what I'm going to do is I'm going to sketch this out, and I'm only going to sketch the first quadrant because that's where it's going to be. We're looking at area and length, so we're not going to have any negative area or lengths. So x, this is length, y, and this is area. Okay, let's graph it on our graphing calculator. So get your graphing calculator out, bring it over. Now, in order to get to putting your equation in, remember, this is the y equals button right here. So we press the y equals, and I just cleared out that equation that was in here. So let's put it in. 130x minus x squared, checking to make sure that it's right. 130x minus x squared, perfect. Now here's the thing. We're working with bigger numbers. 130 is a bigger number. We're used to pressing zoom, so let's press zoom. And we're used to going to standard. Now zoom standard only goes up to 10 and only goes down to -10. And with a number like 130, we're not going to be able to see the graph with zoom standard. So let's explore other options in our zoom menu. If you push the up arrow button, you can get to zoom fit. This will hopefully fit your graph. So let's see what happens. Let's press enter. Oh, there we go. Okay, I have a line. It looks like a line, but I can see that it's a little curve. So I want to zoom out because I want more of this picture. I know that it's probably going to look like a parabola because we have this squared that we've been working with. So what I need you to do is press zoom. And then if you go to zoom out, if you press the number 3, you get back to the original picture, but you have to press enter again. So after you press zoom 3, you have to press enter again. That will make it zoom out for you. Okay, so we can definitely see that curve here, but I want more of the picture over here. So let's take our blinking dot and let's push the right arrow over button. And what I'm telling the calculator right now is I want to see more of this picture. So let's do zoom 3, enter. So this is what I'm doing. Zoom 3, enter. And this is out. Oh, perfect. Look at this really nice curve that I have here. So if you move your blinking dot and you zoom out to where you want to see the picture, it's going to get you there. So let's sketch this. Hopefully I could do a good job, kind of like my calculator shows. Oh, pretty good. Okay, that's pretty good. Here we go. Very nice. Okay. So it is a parabola. It is opening down, which means that we are going to have a maximum value here. So let's just label some points. We do have an x-intercept here. We do have an x and y-intercept here. / y-intercept as well. I bet you that's at 0, 0, because if we start with a length of 0, we probably have an area of 0. That's what I'm guessing that point's going to be. But I'm sure when we turn the page, we're going to see that we're going to be finding these points. Part D. Find the coordinates of the points where the graph intersects the x-axis. Hence, find the x-intercepts, which are the zeros. Now, you have been doing this for your skills practice if you are in my class. And so we are going to be finding the x-intercepts using the calculator. So we're going to be going back to this graph on the calculator, and we're going to be locating this point and this point using the calculator. So let's go and do that right now. Here is my graphing calculator. Okay, so what we need to do is we need to locate the 2 points. So one's here and one's here. So let's press second trace like we've been doing, and we're going to be going down to number 2, which is 0. And you see that we have 2 points. We have this one and we have this one over here. I always like to find the left first, just like we read left to right. So I'm going to look for this one. So with this point, I have to move this blinky dot to the left side of my pencil tip here. So I'm just going to go over to the left side. That's good. Anywhere over here is to the left. I'm going to press enter. And notice that little arrow comes up and then it says go to the right side. So I'm going to go over here. And that's fine. I'm going to make sure that I don't go past the maximum. So I'm going to press enter. And so if you see these 2 arrows here, they should be pointing to where I want to find. So in between these 2 lines should be the x-intercept, and it is. It asked me if I want to take a guess, and my guess is going to come out to my first 0 is actually 0, 0. So I was right in what we said before. So the first one is at 0, 0. Okay. And let's just write down this is length and this is area, because let's remember what x and y are going to represent, okay? All right, and I have my second one, so we're going to do that process all over again. Second trace, we're going to press 2. Now I'm looking for this one over here. this one right here. So I have to go to the left side of my pencil tip, which is going to be over here. That's pretty good. Enter. So again, my arrow comes up, which looks good. And now I'm going to go to my right side. So that's going to be, notice I pass the actual x-intercept to go down to the right side. Good. Now these two arrows, these two lines, my x-intercept should be in the middle of those, and it is. So yes, take a guess. And I get 130, 0. And this is length, and this is area. Okay, part E, we have to state what these two values of x represent. Okay, so this first value, when we have a length of 0 centimeters, our area is 0 centimeters squared. Well, that makes sense because, I mean, if we have no length, we're not going to have an area. So there's probably no shape. Okay, so that's the first one. All right, how about, so that was number 1. All right, how about number 2? When we have a length of 130 centimeters, our area is 0 centimeters squared. Okay, well, how could this be? Because we do have a length. So that's great. We have a length, but how come when we try to do the area, it actually comes out to 0? So that's kind of a mystery. So let's draw it. So let's draw a length of 130, and let's draw a length of, these should be the same, 130. Now, here's the thing that we have to go back to. Our perimeter, if we go back here, our perimeter is 260. So we only have 260 centimeters for us to build this rectangle. That's it. We don't have 261. We only have 260 centimeters. If we take 130 to do this length and 130 to do this length, what does that add up to? That adds up to 260 centimeters, which means we have no width. If you don't have a width, guess what? You're not going to have an area because we took up too much of the centimeters. This is equals. We took up too much of the length. So that's why we have an area of 0, because we have no width. We used it all up for the length. So that makes sense as well. Okay, let's find an equation for the axis of symmetry. So we've done this a couple different ways. First, I'm going to do it by hand, and then I'm actually going to show you that I'm right when we do the vertex, which we're going to do using the graphing calculator. So finding the equation of the axis of symmetry, we have x equals, now I'm going to show you, we usually did negative b over 2a, negative b over 2a. And we could do that because if we look here, we have b and we have a. So b would be 130 and a would be -1. So you could use that. There is another one that IB wants you to know, and that is going to be using the first x-intercept and the second x-intercepts and dividing them by 2. The reason we can do that is because here's the first x-intercept, here's the second x-intercept. Our axis of symmetry happens right in the middle. And if you add two numbers and you add them up and you divide it by 2, you get the middle point. That's what we need. We need the x value of that middle point. So since we have the first x-intercept, and so these are intercepts, right here, these are intercepts. Since we have the first x-intercept, so x equals 0 plus, and we have the second x-intercept, 130 divided by 2. So x equals 130 divided by 2. So our axis of symmetry is going to be x equals 65. And remember, we have to write it like this because it's an imaginary line that cuts through the graph. So if I folded this graph, this side would end up directly on that side because it's directly in the middle. That's what our axis of symmetry does. It sets up that imaginary line. So we have to write it as x equals 65. Now, you could have used this formula. But now you know that there's 2 out there, and I actually like this one, especially since we already did the work for it. I wouldn't need to go back to find B and A, especially that negative throws you off sometimes. Okay, let's find the vertex. So by hand, finding the vertex, what we would do is we would write down our equation, and I'm just changing the area to f of x. We could put a, that's fine. You know what, let's put a, because we're dealing with area. I don't want to confuse you, so let's keep it consistent. So a equals 130x minus x squared. So we know what x equals. So this is the x value of the vertex, and we need to find our y. And so if we have the x, we can just use substitution. We can do a equals 130 times 65 minus 65 times x squared. So notice, I took out the x, I replaced it with the set of parentheses like we've been doing. I put the 65 where the x is, and I put the 65 where the x is. And in my calculator, I can do just that. I press second mode to quit, and I could do 130 times 65 minus 65 squared, making sure I wrote it down correctly. Yes, press enter. And I get 4225, and that's going to be centimeters squared because that is an area. So 4225. So this is going to be my vertex. Okay, and we can even label this axis of symmetry. If you want to label everything on your paper, there you go. Okay, so I'm able to find it by hand. We found another equation for the axis of symmetry. That's great. You can also do this on your calculator. And it's by pretty much using the same buttons that you did. So let's just press graph to go back to our graph. Now, our vertex is that tippity top maximum point. So what we're going to do, just like we've been doing for finding the intercepts, we're just going to press second trace. And I want you to notice we have number 4, which is maximum. So we're going to press number 4. Please notice on the bottom, it says left bound. So what that means is, here's the maximum up here. I need to put the blinking dot to the left of my pencil tip. So we're just going to move that blinking dot over to the left side. And that's absolutely fine. You don't have to go down too far. It's on the left side of my pencil tip. And we're going to press enter. Again, that line gets set up for you. Yay! And then it says, where's the right side of it? So I'm just going to go over to the right side. So I'm at the right side of my pencil tip. I press enter. Here's my 2 arrows, and what it's setting up are the boundaries. It's saying, do you want me to find that maximum in between these 2 lines? And yes, my maximum is in between, so I'm going to press enter. And you'll notice it says 64.999, and then try to get it there for you. Y equals 4225. So I'm just going to round that. Okay, our calculator is so specific. So we just round that to 65, and the Y value right here was 4225. 4225. So using the graphing calculator, I got the same vertex. That is great. So I have a way of doing it by hand, and I have a way of doing it with a calculator, and that was just pressing that second trace and doing number 4, which was maximum. And I hope you notice that there is a minimum too, so we'll be using that in part 2 of the video. All right, and last question, what does the vertex tell you about this whole story with our area now that we've figured out a couple things? So let's write down the vertex, 65, 4225. Remember, this is length, and this is area. So when we have a maximum length of 65 centimeters squared. That's our max length that we could have. Actually, it's not our max length. It's a length that we could have. We could have a longer length, right? So to get that out, because we found up here, we could have a length of 130. We won't have a triangle because we wouldn't have a width, but we could have a length that's bigger. So let's not write a maximum length. That's like when we have a length of 65 centimeters, and I'm making a erase here, I'm sorry. When we have a length of 65 centimeters, our maximum area. That's what I meant to say. Our maximum area will be 4225 centimeters squared. So our length can be bigger, but our area will never be bigger than 4225, and that's what we see in our picture here. So our length, we could get bigger in length, but this area, we'll never go up any further than 4225 centimeters squared. So what does that look like? And just looping back around to our beginning, what does that look like for our rectangle? So we have a length of 65. So remember, length is x, so 65 centimeters, 65 centimeters. Okay. Well, what's our width? Remember, our width was 130 minus x. That was our width. So if we substitute in the 65, 130 minus 65 equals 65. Look at that. It's actually not a rectangle, it's a square, which is pretty cool. So all of these sides, if we did add them up, move this over. If we did add 65 plus 65 plus 65 plus 65, or you could do 65 times 4, either one, we should come out with what, everybody? What was that beginning that we said? 260 centimeters. Okay. We press enter, bingo. We got 260 centimeters. So the maximum area that we could obtain would be 4,225 centimeters squared. Our perimeter will still stay within that 260 centimeters. Our side lengths would all be the same at 65 centimeters. We're going to be using this because someday you might want to maximize your area if you're building something or if you have a field or anything like that. So this problem we are going to be revisiting. Okay, I hope this helped. This has been the area problem involving quadratics.